And now we move on to section 5.2, the uniform distribution. So the uniform distribution is that distribution we discussed earlier regarding which type of continuous distributions. The uniform is the rectangle, and then the normal distribution is that normal curve. So we're doing the uniform distribution now. Okay, so what does this mean, right? How is this different than what we've been doing? Well, we really aren't, because the uniform distribution is just kind of a subset of the continuous. It's a continuous probability distribution, but in this case, all events are equally likely to occur. And there's a little notation that we use for it where x is the random variable and a and b are those boundaries on the rectangle. The probability density function, PDF, is given by the function f of x equals 1 over b minus a. So that's going to be important to us, because as long as we have that interval, a and b, then we can figure out what f of x is. And because this is a uniform distribution and all events are equally likely to occur, well, just like we calculated expected value and standard deviation for prior, then we can actually do expected value, which is the mean, and standard deviation. And this is theoretical because, again, remember that expected value was in the long run, right? So it's theoretical because we can think of it as, in the long run, what's going to happen if I toss the coin an infinite amount of times. So always think about, when we talk about theoretical mean, theoretical standard deviation, a light bulb should go off, and you should think about maybe in the same sense as you did with expected value. It's super simple to calculate. Look at that. All you do is add the endpoints, divide by 2. Even the standard deviation is pretty simple. How we derive these is, you know, kind of lengthy, but it's not important. What we really like is just to know the average distance from the mean, and that's why these two will be important. Now, let's go ahead and do an example of the number of passengers on charting fishing boats. So the data that follow are the number of passengers on 35 different charter fishing boats. The average is 7.9 and the sample standard deviation is 4.33. The data follow a uniform distribution, boom, right, where all values between and including 0 and 14 are equally likely. State the values of a and b, write the distribution in proper notation, and calculate the theoretical mean and standard deviation. Well, if they give us a uniform distribution, they have to give us endpoints, and it seems like they did here. So let's go ahead and start our list. So the first thing we want to do is define a and b. So a is equal to 0 and b is equal to 14. And just so you want to note here on the side, which might be helpful, is that b is usually the right endpoint. So b is usually greater than a, or we could put that a is less than b. So it just means that a is the left endpoint and this is the right endpoint. So we always make a the smaller one and b the larger one. Okay, so that one's done. Number 2 states, let me scroll up a little. Number 2 states, write the distribution in proper notation. So the random variable x tilde uniform AB. Okay, so if x is our random variable, right, so then x is u and then a is 0, b is 14. Okay, so there's part 2, part 1. And then part 3 says, calculate the theoretical mean and standard deviation. So if we calculate the theoretical mean, That's just mu equal to a plus b over 2. And so let's just go ahead and add 0 and 14 and divide by 2, which we can see that's 7. The standard deviation is equal to the square root of a plus b squared divided by 12. Okay, so if we just take the square root of 0 plus 14 squared over 12, we would get, well, we could do this, 14 squared. So let's do the square root of 14 squared divided by 12. 14.041. 4.041. Okay, and these units are the number of passengers, right? So let me go ahead and box these. And I can write a sentence about it, right? I could say the average number of passengers is expected to be 7 people, give or take, about 4 people. Not too bad, right? Okay, so now let's go ahead and do some applications. We're going to have fun here. I know how much you guys like to have fun. So I went ahead and did the picture for you, but so I really want you to concentrate on finding the probability. So let's have some fun. So the probability density function of a random variable x is given below. From this density, what is the probability that x is going to be greater than 1.38 or less than 0.26? So first thing we want to do is go ahead and draw the figure. I think drawing and shading is very helpful. So 1.38, so I would mark this like 1.5 and a half. So then we could see that 1.38 is probably about here. And 0.26 is about halfway here. So let me go ahead and try to draw a rectangle there. And then I'll shade. I'll shade x greater than 1.38 in blue. And let me put that there, 1.38, 0.26. And then x less than 0.26, I'll do in yellow. So that's the area that we need to find. And then we could go ahead and find f of x. We already know what f of x is, right? F of x is equal to b minus a over under 1. So 1 over b minus a is 2 minus 0, which is 1/2. So here, this will be 1/2, which is our f of x. Okay, and then this is going to be kind of funny because we're going to kind of combine things here. So the probability that the random variable x is greater than 1.38 or x less than 0.26 is going to be equal to the probability that x is greater than 1.38 plus the probability that x is going to be less than 0.26. Right? And we would subtract the intersection, but we can see from our picture there's no intersection. So how do we do this? Well, we know what f of x is, so we know the height. We have two rectangles. Let's go ahead and add the area of each rectangle. So the first one would be this blue one. So it would be base times height. So the base is 2 minus 1.38 times the height of 1/2 plus the yellow rectangle is going to be 0.26 minus 0 for the base times the height of 1/2. So let me just go ahead and color code those in for you. Okay, I really wouldn't do much. I would actually just go ahead and use the calculator and just do 2 minus 1.38 times 1/2 plus 0.26 minus 0 times 1/2 and get 0.44. And if you wanted to have the fraction, you could, and get 11/25. So you could either have 11/25 or 0.44. So the goal is to follow the steps, like I would draw the figure first, find f of x, then find the probability. Let's go on to the other one. So let's do an application. Like we said, oh, this is used in a lot of stuff, but we haven't done anything with a lot of stuff. So let's talk about stock. So suppose that a value of a stock varies each day from 8.82 to 21.17 with a uniform distribution. Find the third quartile. 75% of all days the stock is below what value? Round the answer to the nearest cent. So this is kind of involved. We have a lot of information. The first thing we want to do is always draw the figure. So here our figure would be between 8.82. So this is 0. The end point would be 21.17. And then I would say 8.82 is around here. Like that. Okay, and then we could draw a little rectangle now. Okay, and then second step, find f of x. So f of x is going to be 1 over b minus a, which will be 1 over 21.17 minus 8.82. Which will be equal to, let's see, 21.17 minus 8.82, 1 over 12.35. So let's see. And we can make that back into a fraction. So 20 over 247. So here, this will be 20 over 247, which is f of x. And if I wanted to shade, I could, well, let's wait till shading. Let's go ahead and do the probability first. So now the probability they want us to find is the third quartile. So they're looking for 75% of all days the stock is below which dollar value. So the first thing we're going to have to do is understand what that means. So 75% is not over here, right? The third quartile is on, here's like the halfway mark, the median. So that means the third quartile has to be here. Now this value, I don't know. I'm probably going to have to leave it as like a variable C, right? Instead of A and B, use C. And that means that this area over here is 75%. So I'm looking at this dollar value that's equal down there to C, in which breaks that barrier, the third quartile. So here I'm looking for the probability that x will be less than or equal to this C number, which is going to be equal to the base times the height, right? So we know this probability. This probability here is 75%. We know the base. The base here will be C minus 8.82. And let me highlight this. So the base will be this value, like we've been doing, subtracting, right? The area is the probability. And then the height, which will be over here, is going to be f of x, right? The 20 over 247. Okay, so let's write this a little nicer. 75% has to be 0.75 equals C minus 8.82 times 20 over 247. Okay, so if we just want to go ahead and solve for this, we can easily do that by some algebra tricks, right? Okay. I would multiply by the reciprocal, so it would be 247 over 20 times this left side 0.75 equal to C minus 8.82. And then I could just add 8.82 over to the left side. And then I could get C equal to 247 over 20 times 0.75 plus 8.82. And again, we're going to round to the nearest cent. This should be like a dollar amount. So we'll have 247 divided by 20 times 0.75, and then add the $8.82. Rounding to the nearest cent, we would get $18.08. So we would say that the third quartile is $18.08. And if we want to interpret it, we could say 75% of stock is less than $18.08, and 25% of stock is more than $18.08. So sometimes if they give you the area, decipher where that area is in shade, and just, it's kind of an algebra problem, right? You just end up solving for one of the endpoints. So this could be, C could have been over here, and then I would have had to solve for C on the left side. And so just make sure that you understand and draw the figure first, and then that will allow you to decipher which parameter is missing in the formula. But the formula is always going to be probability equal to base times height. And in this chapter, they're always rectangles. So let's try one more application. The length of a professor's classes had continuous uniform distribution between 49.2 minutes and 55.5 minutes. We randomly select one class and find that the probability for the class to run longer than C minutes is 52.9%. Find the length of the randomly selected class. Find C. So this one is actually giving us something that is similar to the previous example, but a little different. So the first thing I want to do is, of course, draw the figure. And so the figure, the endpoints would be here. I would do 49.2 and then 55.5. And we can go ahead and draw the rectangle. Okay. And so step 2 would be find f of x. And f of x is equal to 1 over b minus a, which we know, 1 over 55.5 minus 49.2. And so if I just put that in the calculator, so let me do the whole thing at once. So 1 over 55.5 minus 49.2. And then hit math, hit frac, enter. We get 10 over 63. So this here is 10 over 63. That's f of x. Okay, now let's go ahead and talk about the probability. It says that the probability for the class to run c minutes longer is 52.9%. That means the c that they're talking about is somewhere here. I have no idea. I'm going to say it's probably, I don't know, here, because it's a little more than half, right? And so here is c. And let me draw that line. And so longer means shading to the left or to the right. Longer would be more minutes, so it would have to be to the right. And that area in there is going to be 52.9%. And if we wanted to subtract from 100%, we would know that this area over here is 47.1%, right? Okay, so it's essentially the same exact problem, but instead I was finding the right endpoint up here, and this time I'm finding the left endpoint. Now let's set up our probability problem. See how essential steps 1 and 2 are? Because now if I find the probability that x is going to be longer than c, that's still going to be equal to some base times height. And let's set it up. So this probability that it'll run longer than c minutes will be 52.9%, or in other words, 0.529. The base is going to be equal to 55.5 minus c times the height, which is 10 over 63. So that yellow area is 0.529, which is the probability, and then here's the base. The height is always going to be f of x. Okay, so doing some algebra like we did up here, I could multiply by the reciprocal, so I would have 63 over 10 times 0.529 equal to 55.5 minus c. Now notice here, c is negative, and so I'm going to have to play around a little bit, okay? So if I play around algebraically, I could go ahead and subtract 55.5, so 63 over 10 times 0.529 minus 55.5 equal to negative c. And then we know that we could play with the negatives, and we can get c to be equal to 55.5 minus 63 over 10 times 5.529. And let's just put that in the calculator and see what we get. And it says it's minutes, right? So we'll round to the tenths place. So 55.5 minus 63 over 10 times 0.529. And so I'll round to the nearest tenth, so 52.2 minutes. And don't be alarmed because notice the minutes, length of minutes of class is similar to the probabilities that they give us. Don't confuse the two, okay? One's a probability and the other ones are the minutes of the class. So your answer here again, C, is this barrier, which is 52.2 minutes.